This is checkpoint 3.4, looking at problem number 3a. When a player hits a baseball, its height h above the ground in feet is given by this function. So we can see that h is the name of the function and t is the variable of the function. So h is the output in height, negative 16t squared plus 82t plus 2. They haven't told me what t is yet, where t is the time in seconds after the ball is hit. Okay, now I know what t is. So if I hit the ball and I wait for 1 second, then it's going to be at some height. If I hit the ball and wait for 2 seconds, it's going to be at some height. Then I can plug the time in to figure out how high the ball is going to be. Okay, great. How long after the ball is hit will it return to the ground, assuming it is not caught and it lands on the field? Okay, so I'm going to sketch a graph of this function. There are two important things I'm going to pay attention to. I'm going to pay attention to its y-intercept, and I'm going to pay attention to its leading coefficient, if it's positive or negative. If it's positive, then it would be opening upwards. If it's negative, then it would be opening downwards. So we've got a y-intercept at about 2. The ball gets hit, it goes up in the air, gravity pulls it back down, and then boom, we hit the ground. And they're saying, how long after the ball is hit will it return to the ground? So this spot where it hits the ground, this is what I'm interested in. And I can ask myself, well, what's the name of that point? This point is called a y-intercept. This point is called a vertex. This point is called an x-intercept. So even though they haven't explicitly said what I'm looking for, they wanted to know when it hits the ground. Well, that's an x-intercept. Or really, I guess I should call it a t-intercept because we don't have x's in this problem, we have t's in this problem. I'm still going to call it an x-intercept though. So I need to know when the height of this function is equal to 0. And that's how you find an x-intercept anyways. When you take the function that you're working with, negative 16t squared plus 82t plus 2 equals 0. And it's possible that this thing will factor and reduce. I mean, I could divide everything by 2. I could maybe like divide everything by a negative as well to get rid of that. I could maybe do the AC method and factor it. Like it's possible. I don't know if this thing factors or not. And these numbers are a little bit too intimidating for me to try or for me to care if it factors. I'm just going to use the quadratic formula. I'm going to say t equals, instead of x equals, t equals negative b plus or minus the square root of b squared minus 4 times a times c. Extend the square root bar, and then make a long fraction bar all over 2a. Just going to make sure I did this right. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, feel good about that. So I'm going to simplify the denominator real quick. That's not too bad. Negative 82 plus or minus. I'll leave the square root alone for a moment. That would be negative 32 on bottom. I'd like to simplify the inside of the square root as well. I'll make the calculator do it. So 82 squared minus 4 times negative 16 times 2. Let's do that. 82 squared minus 4 times negative 16 times 2. Did I do that right? 82 squared minus 4 times negative 16 times 2. 82 squared minus 4 times negative 16 times 2. Yes, for sure. Got it. 6852. Let's see if that's a perfect square root of this number. No, it is not a perfect square. So since that square root didn't simplify perfectly, that means that this quadratic couldn't have factored. And let's see, how long after the ball is hit will it return to the ground, assuming it is not caught and lands on the field? Um, they didn't tell me how to round. Like normally they would say round to the nearest second or round to the nearest tenth. It looks like on this one down here it says round to the nearest tenth. So that's probably what I'll do. What did we get on the inside of our square root? 6852. So 6, 8, 5, 2. Since that root didn't simplify nicely, my next step is to just take this entire thing and plug it into the calculator. So negative 82, let's make a fraction. Alpha y equals, enter, negative 82 plus the square root of 6852 all over negative 32, I think it was. Negative 82, negative 32, plus or minus root. Okay, cool. So I wasn't able to type in the plus or minus, but that's okay. I'll just use this and then I will type it in again, but with a minus sign. Okay, so we got negative 0.02. That doesn't make any sense realistically, because we're talking about time. Time can't be negative. If I continue this graph on the left side, it doesn't really make sense for us to continue this graph on the left side because if I'm hitting a ball, it's never going to go backwards. But mathematically, this is what's happening. We have just solved for the x-intercept that would be behind the batter. But that's not what we want. We want the one in front of the batter. So if I retype this, and remember, I couldn't do the plus or minus. So now I'm going to do the minus, and I think that should give us the answer we're looking for. 5.1. Okay, that's totally reasonable. And that's how I'm going to round it. I'm going to round it to the nearest tenth, 5.1. So how long after the ball is hit will it return to the ground? 5.1 seconds. That's how long it will take for it to return to the ground. So there we go. 3A, finding when it hits the ground, which is an x-intercept. That is done.